means. Okay, polymorphism means a same method with a different name. So compilers regenerate the methods with the different names. Okay. For example, you call area with one parameter, area with two parameters. Okay, Jen. Then you've used polymorphism concept. Generally speaking, the compiler regenerates the code. Maybe it may name it as area 1, area 2, etc. It's more of a design aspect of your program than any performance benefit or anything. Polymorphism is not for the performance, it's for the design aspect, which is called polymorphism. Why I'm talking about polymorphism is there is no concept of polymorphism in Go. Go doesn't support any kind of polymorphism. The concept is very simple. Are you short of any method names? No, we are not short of any method names. So why do you want to create the same method? Because we are not following 100% object orientation principles. So Go does not encourage polymorphism. What do I mean by? For example, I create a method called area L comma B float 32 and then float 32. I return L into B and then I create another method called area of side float 32 and I return float 32. I return S into S, which is not supported in Go. There is a way, if you really would like to do, you can even implement some empty struct and do like this. For example, you can create a type maybe R as struct. Okay, even you can do like this. Okay, sorry, you can create a struct, empty struct. Maybe you can put it as R of area. Similarly, you can create type S as again struct. You can implement S as S. Okay, you can implement S as S. This is people say that this is kind of a polymorphism because there is no concrete. There is a type which is called R, which is a concrete type. S is also a concrete type, but there are no fields. So the we already have seen this. We have already seen this. So if you really look at the size of a variable, the size is zero. The size is zero, first thing. And if you look at the not the size of the variable, if you look at the memory of a variable, a basic pointer is created. Okay, a basic pointer means a placeholder pointer is created. The pointer is a dummy pointer, it's not a original real pointer. A dummy pointer is created for R and S. If at all you create a variable. Yes. So we are again, I mean, we are discussing about interfaces concept. Last session we just started using interfaces. This session we will go through more in detail about interfaces. Okay, coming back to the basics once again, if you look at the concept of polymorphism, okay, polymorphism means a method with the different signatures and then different implementation, different behavior. Generally, we call it as a polymorphism. Polymorphism is not is a concept of object-oriented programming, which is very important concept. Polymorphism is not for the performance, it is for the design aspect actually. It's one of the, four pillars of object-oriented programming: encapsulation, polymorphism, data abstraction, inheritance. If you look at all these things, these are the four important aspects of generally object-oriented programming. But Go is not object-oriented programming language. So Go does not support polymorphism. That means I cannot create methods like this, functions like this with the different signatures because Go does not support any kind of polymorphism. The simple question and answer it comes as why doesn't Go support polymorphism? The answer is pretty straightforward. Are you short of method names? Why do you want to give the names? Give different method names. That's the answer I have seen in the very, very long ago from the Google, uh, uh, you know, Golang mailing list, I think. Yeah. So, because it's not going to give any additional performance and Go is not object oriented, the Go doesn't support any kind of polymorphism directly. Basically, there is no concept of polymorphism in Go. That is the straightforward answer. But what we do is, since we are so much accustomed to use object-oriented programming way of doing things, we always feel that polymorphism is very important concept. I'm not saying it is not important concept. Important or unimportant is different, but polymorphism is about the uh, design aspect. Again, I'm telling it is more of the design aspect of the programming. Fine. So if you want to achieve something like that, you can create an empty struct. One of the ways I'm talking about. You can it's a shared behavior because area is a shared the entire behavior is not shared. Uh, the entire behavior is not shared. The reason is the method signatures are different, so it is clearly visible that different behavior is there for both the methods. But how can you achieve polymorphism? You can embrace the empty struct. You know that empty struct, the size is 0. Here also the size is 0. Since the size is 0, if you really create a variable of r1, r1 equal to new of r, and then s1 equal to new of s, we have already observed that r1 and s1 are the variables of r and s, for example r and s1. Then it creates a placeholder pointer. Placeholder pointer means internally a pointer is created whenever the program is loaded. Percentage p, you can see address of r1 and percentage p address of s1. Interestingly, if you really we have seen that earlier as well. Interestingly, if you run it, okay, two variables are created because we are creating two new pointers. Okay, the size is 0. The size is 0. Okay, if you really look at the size size of r1, let me go and then put it as a d is a integer, unsafe dot size of r1, and similarly I put size of s1, I put d1, and then unsafe dot size of d sorry s1. I'm sorry, this is a pointer variable, so the pointer is given as 1. Let's say where, let me show you r1 where r2 comma s2 of r comma s. Sorry for this, I'll explain it. R2 is r, and then s2 is s. Okay, I do the same thing which is of r2, address of r2, because we are taking the address of r1. I tell you the difference. I hope you already knew this. uh, address of s2. Okay, r2 and then s2. Here also we put r2 and then s2. I tell you the difference between these two. You see this. So the address of r1 is already a pointer. So you're talking about the this is an unsafe pointer basically, because a pointer also is a variable. You are actually printing the address of a pointer. You're not printing the pointer. If you print the pointer, the concept is different, but you are printing the address of the pointer. You see this. These four variables you're talking about contains the same address. Okay, the reason why it is 8 bytes is you are creating a new pointer. Since you are creating a new pointer, what happened? There should be some place where it has to store the address of a new variable. Since even though the address is same address, it requires some address. If you go and then get the size of this variable, you get that 0000 because it doesn't contain any memory. There is a little difference between both these two. R1 is what kind of a pointer it is, how much memory is required to store it as a pointer. Let's say simple thing where P1 is int. If you really look at it, P1 also contains some address. P1 also contains some address. P1 also has some address because it's a pointer. Pointer itself has an address, and then address is assigned to P1. There's two different things. We assign an address to P1 and P1 itself has an address. There are two different things. That's what I'm talking about here. Fine. Whatever it is, this is how it works. If you want to achieve polymorphism uh, in Go, if you remember that we discussed earlier as well, the concept is pretty straightforward. The concept is what is the size of R? 0. What is the size of S? 0. So when the size is 0 and 0, ultimately it cannot assign any memory inside the memory inside the memory. It cannot allocate any memory for variable called R1, S1, R2 and S2. It cannot basically. The reason is it's 0. What can it assign? But still it is valid variable with respect to Go. Even though it doesn't contain any memory, it is a valid variable. How can it be made as a valid variable? Go creates some placeholder pointer. That means Go internally creates, whenever the application is loaded, Go create a pointer. Go creates a pointer. That's a dummy pointer actually. It doesn't contain any memory, still it is a pointer. It contains a dummy pointer. That dummy pointer is assigned to R1, S1, R2 and S2. R1 and S1 is a pointers. It contains an address. What does the address is? This address. R1 and S1. R1 and S1 are what? What is the difference between R1 and R2? Basically, R1 is a pointer. R2 is a normal variable. Okay. So R1 contains what? If it is a pointer, what does it contain? Address of the R. What is the address of R? This is the address of R. Okay, why it contains this address? Because it doesn't contain any memory, it gives an empty address. Empty address means I mean to say that a placeholder address. Placeholder, that means it's not a real memory. Real memory is allocated, but Go language, in order to ease the things, it creates some dummy addresses. Dummy addresses means an empty place is allocated and the address is given to R. Whenever you create a variable of R, that empty address is given to R1. But R1 has its own address because R1 is a pointer. So if you really look at it, P1, what is the size of P1? 8 bytes. Okay, any address, any memory, any pointer, basically, whatever the type of the pointer it is, any pointer in Go language, it contains 8 bytes. Based on the, if it is a 32-bit architecture, 4 bytes. If it is a 64-bit architecture, 8 bytes. Any pointer contains 8 bytes. I think that it's a 64-bit architecture, 8 bytes. But does it contain any address or not is a different thing. It itself contains a pointer. We are creating a pointer. The pointer should hold a value, right? That value is what? Address of the another variable or address of some memory. Here address of some memory, here address of some other variable. So pointer also contains 8 bytes. If you look at the size of P1, it contains 8 bytes. But what pointer it contains? Here it contains nil, no pointer. But here it is not called as nil. Here it contains some dummy address. Dummy address means a placeholder address. It's very important concept in Go. That is how the empty structs work in Go. Empty structs are valid variables even though it doesn't contain any memory. The moment a variable is created for R and S or any other dummy structs, whenever you create a variable for a dummy struct, similarly, if I create something called okay T1 is empty struct, you can create like this. We saw that T1 is an empty struct. What does it contain? A struct. It's an anonymous struct. What variable, what fields it contains? It contains nothing. No fields or not fields it has got. So if you really look at T1, if you really look at T1, T1 also contains the same address because all empty structs are given some address means it's not a even. If you really look at it, the address of this is actually a different segment. Let's say I create a variable where num is int equal to some value. Where num is int, I want to print okay size of num and address of num. You see that this address is different, these addresses are different. You see the difference. This is real if the structure is not empty, let's say for type t is a struct or maybe a is a variable, and then I got to create t2 as t, then I got to print over here this is T2 and then T2. This is a different thing because it's a real structure. Whether the value is zero because we have just created variable, so the zero value is given. Okay, that is a different thing. We have not assigned any value so that it assigns a value called zero. But now it contains the real memory for a variable the type called T1 or sorry T with a variable called T2. The difference is here. That is the difference. Okay, why I'm talking all this is there is a reason for that with respect to interfaces as well. Okay, fine. I hope you understand the concept. This is what the polymorphism with respect to Go. This is what the polymorphism with respect to Go. I don't prefer polymorphism because it understand that polymorphism is not required for Go. Still, I have seen that many folks think that how can you do polymorphism in Go? Uh, Generally, you don't need to do. Okay, you don't need to do because it's not a concept of Go. Still, your design or you want to design or you have a lot of influence from the object-oriented programming, then you can implement polymorphism on just on an empty struct, empty types, and then still you can implement polymorphism. There is no problem. You can do like this. Okay, let me put it as a polymorphism. Two things we need to keep it in our mind here. Number one, you can achieve polymorphism by implement empty structs or empty types. In fact, not necessarily to be struct, you can empty type, but empty struct and empty type are different things. Empty type means you may think that I can also create a variable called byte, a type called type, but the difference is byte contains one byte but empty struct contains 0 bytes here. So still it still con allocates 1 byte, but here it is absolutely allocate 0 bytes. So that's the reason why we create empty struct. So empty struct works as just a placeholder. No memory is allocated for the struct. So the most important thing is you should know the difference between this and this. Why R1 contains, if not star, why R1 contains 8 bytes? You should know that. Why R1 contains 8 bytes? If I go and then print R1, you should know the difference. Very, very important. Size of R1, I can put it as address of R1, address of S1, and then R1 and S1. You should know why does it contain 8 bytes. Very, very, sorry, where is it? 50. If you know the difference, you understand the concept. Why it contains 8 bytes and then why does it contain 0 bytes? That's very, 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 very important. Do you know the difference? Why does this contain 8 bytes? Because this is a pointer. You're directly checking the pointer. Pointer is a variable. Pointer is a variable. It's a pointer. R1 is a pointer which holds the address of another variable. Okay, so pointer itself requires some memory, which is called 8 bytes. If you look at P1, P1 is 8 bytes. Okay, P1 is 8 bytes. Why P1 require 8 bytes? Because P1 is a pointer which should hold the address of another variable. So another variable address is also 8 bytes on 64-bit machine. So P1 is 8 bytes. Does P1 contain any memory, any address? No. Here it doesn't contain any address. Still P1 is 8 bytes. What value P1 contains? Nil, because no address is assigned to P1 here. But P1 itself contains 8 bytes. Similarly, if you look at R1 and S1, R1 contains 8 bytes, but the value inside R1, it is not nil here. Here it is not nil. It contains some address. What is that address? This address. Some dummy address. Why dummy address? Because R and S are empty. R and S are empty structs. Empty structs doesn't contain any memory. Empty struct doesn't contain any memory. So what Go does? Go creates a placeholder pointer. I can name it as placeholder pointer. These are generally you can see the difference between this address and this address. It's a different address. Somewhere in some other region it is created. It's a placeholder pointer. Okay, this is how the polymorphism is uh, implemented in Go. This is how the polymorphism is implemented in Go. Uh, if you are really concerned about polymorphism. But for my personal choice, I don't use polymorphism because Go itself says made the polymorphism is completely avoided polymorphism. So I don't go for polymorphism. But I have seen many folks who are from the uh, pure object-oriented programming like Java, C Sharp, and all, even including me, I also used them because I also initially used to do polymorphism and all, try to adjust things in Go by implementing polymorphism, and later on I avoided because I understood that Go is not an object-oriented programming language. But however, that is the concept.